Welcome back, team. You're tuned into Cloud Bridge Tech Labs. I am super excited to kick off Session 7 of Phase 1 with you today. Look, we're focusing on the absolute bedrock of web communication right now, the fundamentals of HTTP and HTTPS. If you've ever found yourself wondering how your browser actually talks to a server, or, how to lock that conversation down securely, you are in exactly the right place. This explainer is going to lay down the foundational knowledge you absolutely need to crush it as we move through Phase 1. Let's get into it.
Okay, let's dive into this. Here is our roadmap for today. We're hitting the HTTP plain text problem first, then securing data with HTTPS, covering essential HTTP communication methods, troubleshooting HTTP status codes, and wrapping up with your mandatory Phase 1 practice.
All right, Section 1, the HTTP plain text problem.
So before we tackle the problem, we really need to define the tool itself, right? HTTP stands for Hypertext Transfer Protocol. At its core, it's the protocol used for all that basic communication between a web browser and a web server. You can think of it as the agreed-upon language that your computer and a remote server use to talk back and forth. It's what allows you to load web pages, read text, view images. It is literally the engine of the web.
Well, here's the massive catch. The fundamental flaw with standard HTTP is that all the traffic is sent in plain text. Imagine writing a super confidential message on the back of a standard unstamped postcard and just handing it to a courier. Anyone who handles that postcard along its journey, the courier, the sorting facility, the delivery driver, they can just flip it over and read exactly what you wrote. No way around it. That is exactly how plain text HTTP operates across the internet.
So the crucial point is this. Because it's exactly like that postcard, anyone who manages to intercept that network traffic can read everything perfectly. And we are talking about highly sensitive information here. If a user logs into a system using just standard HTTP, their passwords, their private data, their security tokens, they're all completely exposed to anyone eavesdropping on the network. In any modern environment, leaving this kind of data unencrypted is just a massive security hazard.
Which brings us to Section 2, securing data with HTTPS.
The solution to our postcard problem is HTTPS, which simply stands for Secure HTTP. This protocol uses encryption to completely protect your communication in transit. To go back to our earlier analogy, if HTTP is a flimsy postcard, HTTPS is a heavily locked steel briefcase. You put your message inside, scramble it with some complex encryption, lock it up tight, and send it on its way. Even if someone intercepts that briefcase, they can't open it, and they certainly can't read the scrambled data inside.
And this brilliantly illustrates the difference. If you send your credentials without HTTPS, someone listening in sees exactly this. Username equals admin, password equals 123. Boom. It's right there for the taking. But with HTTPS, that exact same data transmission becomes completely encrypted. The communication is secure, and any eavesdropper, they just see a wall of mathematically scrambled nonsense. It's an absolute night and day difference in security.
Let's move to and see how this builds our foundation in Section 3, Essential HTTP Communication Methods.
When your browser or application actually talks to a server, it uses specific action verbs. We call these HTTP methods. The 4 core methods you're going to use constantly are get, post, put, and delete. A GET request is exactly what it sounds like. You use it to fetch data, like loading a web page. A POST request is used to send new data up to the server, like when you submit a login form. PUT is for when you need to update existing data. And delete? Well, that one's pretty self-explanatory. It's used to remove data from the server. Mastering these 4 actions is essentially mastering the core grammar of the web. Now, as DevOps engineers and cloud practitioners, you know you won't always be using a web browser to make these requests. Often, you're going to be living in the command line. And the tool of choice for this is curl. You can actually test these protocols directly in your terminal. For an unencrypted test, you'd type curl http:/example.com. To test a secure connection, you just change the protocol on the command, typing curl https:/google.com. It's incredibly straightforward, but honestly, it's a vital tool for verifying exactly how a server is responding.
All right, Section 4, troubleshooting HTTP status codes.
Every single time you make an HTTP request, the server answers back with a numerical status code. Here are the main ones you absolutely must commit to memory. A 200 means success, everything worked perfectly.
A 301 is a redirect, basically telling your browser to go look somewhere else. Now, the 400 level codes mean the issue is on the client side. A 403 means you are forbidden from accessing the resource, and the famous 404 means the resource was simply not found. Finally, the 500 level codes mean the server itself has a problem. A 500 is your generic server error, while a 502 indicates a bad gateway.
Now, what's really interesting about this slide is the real-world application. Imagine you get paged in the middle of the night. Your monitoring tools are screaming, and the primary application is giving users a 502 bad gateway error. So what does this actually mean, and where do you even start looking?
Well, a 502 bad gateway essentially means that one server on the internet received an invalid response from another server. In a standard DevOps architecture, this narrows down our suspects pretty quickly. You should immediately look into three prime possibilities. First, is the back-end service completely down? Second, is there an issue with your reverse proxy failing to route the traffic correctly? Or third, has the underlying application itself just crashed? Knowing that a 502 relates directly to these specific back-end routing and service availability issues is going to save you precious time during a major outage.
And that brings us to Section 5, Mandatory Phase 1 Practice.
To formally complete Session 7 and advance to the next phase of your training, the following practice steps are totally mandatory. You must open your terminal and use the curl command to make some requests. I need you to actively observe the status codes coming back. Then, in your standard browser, I want you to intentionally open both HTTP and HTTPS websites and physically verify that lock icon that indicates a secure HTTPS connection. Checking off this list in your own environment is an absolute requirement before you can move forward. As you jump into your terminals to knock out that practice, I want to leave you with a final thought to chew on before our next session. You now know exactly how to secure data in transit using the locked briefcase of HTTPS. But what happens to that data when it reaches its destination? The briefcase is opened and the back-end server itself is fundamentally compromised. Think about that for a second. If you found this explainer helpful, please do hit that like button and subscribe to CloudBridge Tech Labs so you do not miss Session 8. Happy troubleshooting, team, and I will see you in the next one.